We will now be having our third session for the day on the topic Bacterial Contamination and its Controls. I would like to introduce our speaker for the session, Dr. KVTS Pawan. He is a seasoned life sciences professional. Can we please have a huge round of applause for Dr. KVTS Pawan? A very warm welcome to you, sir. He is a seasoned life sciences professional with more than 20 years of expertise in biochemistry, microbiology, and biotechnology, specializing in innovation and sustainable solutions in agriculture, bioenergy, and genetic engineering. With over a decade of international experience, he is currently at Catalysts Biotechnologies Private Limited, dedicated to advancing research and fostering collaboration in biochemistry, in biotechnology. Please put your hands together once again for Dr. KVTS Pawan. Along with him, we have on the dais Mr. Munish Madan and Ms. Mehak Madan. Can we please welcome you both to join us for the session? A very warm welcome to both of you. A gentle reminder for our speakers to please keep in mind the allocated time for the session, which is 30 minutes. For your reference, there is a timer on the screen. Thank you so much. Over to you.
Good afternoon, all. I think it is a very difficult session post-lunch, but I think I'm not going to make you interesting. The topic is going to make you interesting because that is what is very well connected with all of you, day-to-day life. And it is like every moment of your journey in the plant. Coming to our company, I'll just take few minutes on this slide. Catalyst Biotechnologies Private Limited is a 20 years old company. So we have been working in this particular industry, including sugar industry, distillery, brewery, paper, and biogas verticals from past 21 years. And we have our footfall across the globe. More than 23 countries, we have our presence with greater than 200 employees who is sitting across the globe and helping us to provide solutions to our customers. So when it comes to the number of products, we have more than 200, 300 products, but when we group them into certain groups, it will be around 39 groups. So which will provide the solutions to our customers. So we have more than 850 clients across the globe where we are providing solutions. And till now, we are very proud to say that we have saved more than 8,200 crores worth of losses to our clients. So it shows the quantum of the work which we have been doing to support the clients. Today, as you all know, my topic is contamination. So basically,
please talk later. Sorry, let us listen for 30 minutes.
Contamination is very well associated with all of us in the life. We actually want to delete it. We don't want to have contamination in our process. As we all know, if contamination enters into the process, we know it is going to create loss for us. So we want to delete the contamination, but unfortunately, it is not possible in all plants. So what we have to do is we have to adapt to it, and then we start working on it in terms of making it how we can work along with the contamination to see how we can increase our productivity. Basically, contamination in fermentation. So everyone will be talking about contamination. So when contamination happens in the fermentation, what it is going to do? It is actually creating a lot of challenges to our processes. It creates losses to us. For example, when contamination comes into the picture, contamination comes into the plant, into the fermentation process. So what it will do is it will try to compete for nutrition along with yeast. As we all know, yeast is the organism which will produce us alcohol. But when contamination comes into the fermentation, it competes with the yeast for the nutrition and sugar. So it takes away the sugar and the nutrients that are required for the yeast so that the yeast will not be able to perform, and ultimately it leads to the losses. It also creates challenges by producing byproducts like organic acids, acetic acid, lactic acid. People who are in the plants, they might be knowing these terms, lactic acid and acetic acid. When these acids are produced, actually these acids are detrimental to the yeast cell wall. It will disrupt the yeast cell wall. Because of that, the yeast will not be able to perform up to its maximum potential, and sometimes it will also kill the yeast. So yeast will go die, and you will see that yeast is settling down, and it is we see a lot of dead yeast cells in the microscope. Ultimately, the overall implication or effect of the contamination is losses. So we don't want to have losses to any of our customers or any of one of you. We want you to do more than what your production capacities are. We want to achieve more production capacities. In turn, India will get benefited out of it from the ethanol blending program. And of course, we also see a lot of us are speaking about stuck fermentation. So this stuck fermentation is also a effect of contamination. How do we know that contamination has come into the picture? So when we want to understand, we say that yeah, contamination. But how do we know that contamination is there in our process? What are the indicators that will give us a brief understanding about there is something is there in my process which is creating challenge? So the first one is sluggish or slow fermentation. When you see the fermentation has to happen at certain speed, or we say that gravity fall should happen at set particular trend. If that is not happening, and if the fermentation is getting slowed down, it ultimately shows us or tells us that something is wrong with the process, and it may be majorly due to the contamination. The second indicator in the process or the fermentation is high pH drop. Suddenly we see a steep decline in the pH of the fermentation broth or fermented wash or wort. So it indicates that definitely there is a contamination. It basically happens due to the organic acids which are produced by the bacteria or the any other microbes. Ultimately, the third indicator will be less alcohol which is produced in the fermentation, and it is not matching or correlating with the DS which we have used. We have taken certain amount of DS, but the same amount of alcohol is not getting produced. So this is also an indirect indicator. It could be due to two reasons. One may be the enzyme efficiency, but a majority of the times it will be due to bacterial contamination. And the second one is when the plants which are producing ENA, so we will see a lot of off flavors, odors, failed organoleptic properties. So all these indications will also tell us that contamination is entered into our process. Next one is the it is like our process will go wrong, and we will not be able to maintain the process conditions. Fermented vessels, lines, everything will get choked, and we will see a huge delay in the fermentation cycles. So due to these things, we can clearly understand that there is a big challenge of contamination, and these are basically the indicators. As a layman or a person who wants to understand without doing any data analysis or without using any analytics, we can at least understand, yes, these are the 5 parameters which are very important to monitor. Yes, the ultimate bug or the culprit is contamination. What are the common microbial contaminations we see in our fermentation? So if we categorize them into different types, the first one would be bacteria. When it comes to the bacteria, we have 2 types of bacteria which actually create or damage our process or our fermentation process. The first one is the lactic acid bacteria. This is very prominent in the grain ethanol mills compared to the molasses. And second one is acetic acid producing bacteria. So these are the 2 kinds of bacteria which will be hampering our fermentation process. The next one is yeast. Yeast is also, we may think yeast will produce ethanol, but there is certain kind of yeast which we call wild yeast. This yeast creates lots of off flavors. It will create bunches in the fermentation. and because of that the proper mixing won't happen, and the nutrients will be taken away by this particular yeast, and ultimately it will leads to the damage to the yeast which actually producing alcohol. So we also need to keep a tab on wild yeast contamination in our fermentation process. Next one is molds, which comes from our raw material, basically maize and then rice. When we procure it, and if we won't store it properly, the proper storage conditions needs to be maintained, or proper milling conditions needs to be maintained. If these things are not maintained, the grains will get contaminated. Of course, it can also happen at the farm level. But when we have not taken certain precautions in terms of storing the grains, so the aspergillus and penicillium contamination can happen, which is basically the culprit for the aflatoxins, which we have keep on hearing in the industry. The aflatoxins will go into the DDGS and it will not get destroyed even at higher temperatures, and because of that the feed manufacturers will be having challenges and they won't buy if the aflatoxin levels are more than 20 ppb parts per billion in the DDGS. It is very difficult for the feed manufacturer to buy that, because as per the norms they cannot use that in making the animal feed or poultry feed. So the mold contamination is also one of the aspect which we have to keep a tab. Normally when we see the plant, we see these kind of pictures. So this basically indicates or gives us an information that plant is not properly maintained. Somewhere the nozzle is lying down and the pipelines were choking, and then a lot of sedimentation is there in the other dead or settled yeast is there. And when people are washing or cleaning or doing the CAP in the plant, they won't take care of the proper SOPs, or they won't take care of procedures which they actually need to follow. Because of this, the contamination enters into the process. So this is how we can see the contamination. It is a contamination slide where normal yeast will be visible with even at 100x, but if we want to see the bacteria, we have to go up to 1000x microscope. So basically when contamination enters into the picture, it hampers our process, it disturbs our process. So what we have to do then, if we know that yes, these are the indicators which are hampering our process, and these are the at what level the contamination is happening. So what we have to check, or what kind of precautions we need to take, or how do we actually find out whether it is really contamination is there or not. So what we have to do is, we have to check certain parameters like viscosity, total volatile acids, pH, total bacterial count, and biofilm formation. We can see a thin layer of biofilm is formed on the fermented wash or maybe broth, and even on the liquefaction tanks certain times. So, and also we need to assess the byproducts. The byproducts basically the lactic acid, acetic acid, and glycerol. Acetic acid, lactic acid will give us an indication of bacterial contamination, whereas glycerol will give us an indication whether the yeast has come under stress or not. If the glycerol levels are increasing, that means our yeast which we are using in the process is it is undergoing stress. And next one is yeast microscopic observation. We have to see the microscopic observation of yeast to understand its status, whether it is in the really growing phase, budding phase, or it is going under the dead phase. So if it is on dead phase, it is very detrimental for us. So we have to take actions before it goes into the dead phase. And what needs to be checked? So we have to basically check, or we have to do the sampling from these places like culture vessels, pre-fermenter, fermenter, clarification tanks, clay tank, day tank, process water storage tank, culture vessels, PF, fermenter, wash, condensate. So these are the samples which we have to collect and do or check these parameters which were mentioned, so that we get a clear picture why our process is getting disturbed or why there is an imbalance in the process. Basically, what happens when contamination enters into the process? We understood that these are the indications, but what really happening inside the fermenter? So as I mentioned it to you, there are two kinds of bacteria which are actually detrimental for ethanol fermentation. One is the lactic acid bacteria. Second one is the acetic acid bacteria. So we call them as simply LABs and ABs. So when lactic acid bacteria enters into the fermentation, it can do two things. One, it will produce one molecule of lactic acid and one molecule of alcohol also. But when it is in a undergoing rapidly, it is growing, that time it will produce more of lactic acid. So it is anyway detrimental. So one, instead of making two molecules of alcohol, it is making one molecule of alcohol and one molecule of lactic acid, which is not, we don't want. And the second one is acetic acid bacteria, where what it will do is it will not only taken up all the nutrients and then sugar from the system, it will convert the alcohol which is already produced. The alcohol which is already produced will get converted into acetic acid. So because of that, we see sudden drop. In the fermenter, we feel like, okay, it is fine. But during giving more retention, we find that this acetic acid is increasing. That gives us an indication that yes, there is a acetic acid bacterial contamination. So we want to understand why it is not favorable, or why it is not acceptable by us producing acetic acid or lactic acid. So here we see the mass balance, where one molecule of glucose will produce 0.644 molecules of ethanol. I'm saying it in a layman language. So whereas one glucose molecule will produce 1.02 molecules of glycerol. But whereas one glucose molecule will get converted into one molecule of lactic acid. That means the more lactic acid is getting formed in the system, it is actually indirectly reducing our ethanol percentage or ethanol yield. The same way acetic acid, if one molecule of glucose is used, it will produce, bacteria will produce by eating one molecule of glucose and will produce 0.6 molecules of acetic acid. So we don't want to happen this. This is what I was talking about, the competition between bacteria and yeast for sugar molecules. So we don't want to produce these molecules. We want to divert everything towards ethanol. Basically, when it comes to the ethanol industry, especially the grain ethanol industry, lactic acid bacteria is more prominent. It is very tough organism. It can grow in any condition. It can grow in presence of air, in absence of air. It can grow even in presence of alcohol, which is very, very detrimental. Normally, we think that alcohol is a sanitizer, and if we use sanitizer, bacteria or the microbes will die. But the lactic acid bacteria will not die even in presence of alcohol. So because of that, what happens is, in the anaerobic conditions, the bacterial growth will be more, and we tend to lose more and more alcohol in that. Another one, which is a leuconostoc bacteria, which normally won't we see in the grain fermentation. It will be mostly in syrup or molasses fermentation. It also comes under the lactic acid bacteria class or category. People will say some bacteria are useful for us, like probiotics, but here in this particular industry, in ethanol industry, in ethanol fermentation, we don't want bacterial contamination. As I mentioned it to you, the second bacteria which hampers our fermentation process is acetic acid producing bacteria. It converts alcohol to acetic acid. So that's where I mentioned it. It can happen in beer well, fermentation vessels during retention. So both aerobic in nature and can only survive in pre-fermenter. It is like aerobic. It can only survive in aerobic conditions. So that's where it is somewhat better to manage in ethanol grain fermentation, but lactic acid bacteria will be more tougher. But one disadvantage will be it is more toxic than lactic acid bacteria. When acetic acid bacteria comes into the picture, it actually makes pores into the yeast cell wall. Because of that, yeast nutrients will come out and yeast will die. So it, it is not as prominent as lactic acid bacteria, but yes, it is also a detrimental thing for ethanol industry people. This slide will give us a brief indication or vague understanding what happens if contamination enters into the fermentation process. When we see yeast will multiply at 90 minutes, that means one yeast will become 2 in 90 minutes, whereas the bacteria will take only 20 minutes on an average. So if we see calculate the number of cycles that yeast will grow in 7.5 hours, it reaches around 32 generations. But whereas the bacteria, which is we call it as slow growing bacteria, will reach 1024 generations. But if the bacteria is fast growing, then it will go to 1,48,000, 1,04,000. So these many multiple cycles the bacteria can grow in 7.5 hours. That means in the initial phase of fermentation, if bacteria enters into the picture, that means we see the fermenter will be stuck. It won't show any further gravity fall. So that is where this gives us an indication like how intensive these bacteria are and why we should control it in the initial phases itself. We should not wait for longer time. We have to control it in the initial stages itself. What we have to do to control the bacteria? So we have to have regularly analyze the quality. So we have to keep analyzing it at regular intervals, like lactic acid load. There are certain equipment or handy equipment which are available to measure lactic acid. It is a very simple method. Anyone can do. Even a small plant operator without having any scientific background or anything, he can do it on his own. It is a simple glucometer kind of thing जो normally हम blood glucose measure करने के लिए use करते हैं. It is as simple as that, and it works on the similar principle. So these kind of equipment will be definitely helpful in terms of monitoring the process. And of course, HPLC is another tool. Many speakers before me also emphasized on analyzing the data using HPLC and other advanced tools like NIR, near infrared spectroscopy. So these are the tools which helps us to understand how we can monitor the process quality, and accordingly we can take steps. The next one is hygiene part. So we cannot compromise on hygiene. If we compromise on hygiene, that is going to be very detrimental. So we put little more effort on hygiene part. It helps us in reducing all these firefighting. So there is a saying that if we start good in the beginning, so the whole thing will go well. The same way, if we do proper CIP and we take care of hygiene processes or hygiene practices very well in our plant, we can completely avoid the contamination. And next one is following the SOPs. Many of the plants, they will be having SOPs which are not properly documented. So one good aspect is, even some of the speakers has emphasized on it, have the SOPs and available at all the levels, from the down the level to the top level. These SOPs, if are available, it helps us to see how do we follow the process. And we can also have checkpoints in it where we have to actually take the samples and do the analysis and then accordingly take the corrective measures. So having these SOPs, like what temperature we have to maintain and how we have to maintain the hygiene, whether we are doing CAP in the right way or not. So these are the ones which has to be documented. It has to be given to everyone in the plant. Most importantly, it's like we should have a dedicated team who takes care of CAP process. If we do this properly, almost more than 90% of our plant problems will be avoided. Prevention is better than cure. So don't allow your profits to go down. Please focus on CAP. And next part is like, what is the difference? And we have a crude method of estimating VFA. We think that VFA will give us a direct indication, but most of the times it won't give us the real picture in the plant or in the fermentation which is happening. This is because the difference between both the molecules chemistry, and both the molecules will get distilled at different temperatures and different way. So because of this, what happens is when we try to measure the process condition on the basis of VFA, we may not get the clear picture. So we have to exactly measure the lactic acid and acetic acid levels and other byproducts levels so that we get a better picture of what is happening inside the fermenter. So that is the reason it is the one of the tool which is available, which is affordable by the industry, is HPLC. So if we use HPLC, we can actually measure these things. Having in-house HPLC would be more preferable. But in case if you don't have HPLC, probably you can have a third-party analysis, or maybe probably you can get it done from your vendors. So just to give you a brief about HPLC, what it happens, how it will be able to distinguish different molecules or different byproducts which are formed in the fermentation. So when we inject the sample into the HPLC, so what happens is different molecules will get separated at different time points, and it will give us a peak which shows us, and this is a well studied subject where everyone knows if a glucose peak is there, means at what retention it has to come. If it is a lactic acid peak, at what retention it has to come. If it is ethanol peak, at what retention it has to come. So this will give us a clear picture, like what are the byproducts which are getting formed. Even it is a very good quantification tool. We can actually quantify by using this to understand how much byproducts or how many byproducts are forming in the process. It is very, as I mentioned it to you, it is a very high sensitive equipment, and then we can get clear picture. Not only we can quantify it, all the byproducts we can quantify it, so it will be helpful to take the necessary actions. So this is how the HPLC peak looks like, and most of you may be familiar with it when you are getting the reports, or maybe when you are getting the results from your plant or from vendors. So it gives you indication like what are the byproducts which are forming, and you can focus on the products which I mentioned it, like glycerol, lactic acid and acetic acid, to see how you can minimize it. The more you minimize these three, the more alcohol peak will raise. So we have to focus on these aspects. Next one is, when nothing is working, we have to rely on antimicrobials, which basically works in a different mechanisms. So when these antibacterials will disrupt the bacterial cell wall, or it may hamper the protein synthesis of the bacteria, or it will inhibit the DNA replication process. Because of that, the bacteria will stop growing. So when we select these antimicrobials or antibacterials, we have to have certain parameters in our mind. It should be wide spectrum. That means it should not only work on one single bacteria, it should work on different bacterial types, like lactic acid bacteria, acetic acid bacteria, any other kind of contamination that comes into the system. And it should not be toxic to yeast. Majority of the people, they will use certain antimicrobials which creates problem to even yeast. So when we are selecting the antimicrobials, we have to have emphasis on one aspect, which it should not hamper our yeast, because yeast is the one which has to produce alcohol for us. As I mentioned it to you, it should target both the gram positive and gram negative classes of the bacteria, and it should be with minimal human contact. That means when these people are applying it or using it in the system, we should actually minimize the contamination or the contact with the people, so that it will be safe for them also. And we should select a synergistic blend of these antibacterials, so that we can avoid resistance. As you all know, maybe in the newspapers also it is coming that the antibacterials are creating challenge of resistance. So if we want to avoid the resistance, we have to use a right blend of these antibacterials and in an alternate way, so that the contamination won't come into the resistance part will not get developed in the system. The best case is, it is always better to go for a tailor-made product. So do little understanding about what kind of bacteria is entered into the system, and based on that you can take a call what kind of antimicrobial I have to use. So at the end, ultimately we want to manage the stress on yeast. So there are certain factors which create stress on yeast, so we want to manage that so that it will give us the good yields. Basically, when we select the best yeast strain, which will help us in terms of managing most of our fermentation aspects. If the yeast is tolerable to any of these variations in the system, that means our job is half done. So select the yeast, the best yeast which is available in the market, which is having high tolerance levels, and then it should also be tolerant to the high sugar loads, high pH range, and should be able to manage the process variations. So selecting the yeast is one of the important aspect. And the next one is select the best nutrient for the yeast. When it comes to the nutrition, previous speakers are also emphasized on the macronutrients and micronutrients. So we have to have a right blend of micro and macronutrients so that the yeast will grow happily, it produce good yields for us. And the next one is the antibacterials. So if we use the right set of antibacterial blends, so that bacterial contamination will be addressed. Ultimately, the yeast, the stress which is coming on the yeast needs to be managed. For that, we have these three aspects. One is the having the right yeast, the right nutrition, and the right antimicrobials. This slide indicates the monetary aspects of it, like how much we are going to lose if the contamination comes into the picture. It's like if any 100 KLPD plant will incur a loss of 15 crores in case if they don't take care of the lactic acid bacteria. If the lactic acid bacterial contamination is high and it is producing 10,000 ppm of lactic acid, that means a 100 KLPD plant will straight away lose 15 crores in a 300 working days cycle. So this is the slide which is very important and which gives us the indication like how much losses we are going to incur if we don't control the contamination. So what we have to do, and majority of the places or majority of the plants we have observed certain things which I would request all of you to take care. One is have a good microscope present. Some of the points which were listed here, we keep hearing from the plants that हमारे पास microscope नहीं है, हमने indent किया है. And we also have the CIP in process. Have the best CIP in process. Maintain the logbooks. Keep having the logbooks properly updated. It is not just for sake of updating it. Please have the logbooks updated properly. And then provide training. Please provide training to all the levels with proper in a proper way and keep rotating it. It's like don't do it for one time and then keep going it. So training needs to be done at periodic regular intervals. And then understaffing is also another aspect which we have noticed that creates these kind of challenges. So this is the cheat sheet. Basically will help you what are the checks and balances needs to be done at shop floor, and how do we manage the hygiene practices, and how we have to equip our lab with good analytical tools so that we have a better control on our process. And last but not least, training is very important. Please keep provide the training to all your staff and have a regular calendar for the training aspects. Thank you.
Thank you so much, Dr. Pawan. The floor is open for any questions from the audience. Very quickly, anybody with any thoughts? Any questions? Yes. Can we have the mic, please? Okay.
The desired rate of acid in the fermentation.
Sir, it should be as minimal as possible. When it comes to the acetic acid, I think it should be less than 800 ppm. But when it comes to the lactic acid, it should be managed below 1000 ppm.
These days, many plants are facing the problem of water management. So thin soap is being recycled into slurry. How much thin soap we should be safely recycling into this slurry?
Sir, it depends on a lot of parameters. It is not only the contamination, you also need to see the pH and other aspects of it.
conditions and the Indian industry?
It is we cannot generalize it. Actually, we have to do the analysis and then see whether it can be recycled or not. If we want to recycle it, then we have to use certain measurements and products to control the contamination.
So whenever we are recycling streams, it is coming out of the fermentation, right? So if our fermentation is not good enough or it is not in the healthy condition like we want it to be, so the recycling streams will also have these contaminants like lactic acid, acetic acid already built up, which will further impact your fermentation. Hence, that is why we say that it is very important to maintain your process at each batch. Because if one batch gets ruined, the next batch, and it will be a subsequent effect on other batches as well, because you will be recycling each and every thing.
What kind of with the permissible range of acids, if that is maintained,
Yes.
how much thin slope we can say?
There are kind of, when we say that it depends on the yeast stress, how much the yeast can handle. So in fermentation, if anything above 1500 ppm of VFA levels, yeast will get slow. So that is what it has to be below that. So that's the limit of it. And then, but problem here is that we might be measuring volatile acidity, but who is measuring lactic acid? Because nobody, most of the people does not have even HPLC here in India. So that's why we came up with this solution of where we are recommending a kit of Merck, which it's a very small instrument which you can have. And lactic acid is giving you a more loss than volatile acidity.
Is there any US FDA Federal Register reference number of antimicrobial you can suggest?
There are some because it found a trace in your DDGS because of you using some kind of antibiotics and then it goes into the DDGS. There's some which is like some antibiotics which can be used like virginiamycin and monansin, which are possible, which can be used. But then it's kind of it's like it goes in a it goes in after distillation. It is a very.
Is there any US Federal Register reference number? Does that exist?
That I'm not aware of.
For these antimicrobial.
Sir, as sir has mentioned, monansin and virginiamycin are allowed to use even in feed industry up to certain ppb. So probably we have to back calculate how much can be used in the feed industry. So accordingly, we have to optimize our dosages.
Thank you.
These kind of antibiotics are already used in feed industry, so that's why they allow it.
That's true, but for the information's sake, I just wanted to know if there any federal registration reference number exists.
Exactly the number to available. We didn't remember, but virginiamycin and monansin are allowed. Monansin.
Oh, thank you.
Well, thank you, everybody. With this, we will conclude this session for the day. Thank you so much to all our wonderful speakers. Can we please give them a hand? Thank you, Dr. Pawan, Ms. Madan, and Mr. Madan. Please have a seat. We would quickly request you for a photograph. Thank you so much.